Good morning, everyone. Thank you very much for the introduction, Alison. My name is Dr. Sean Watson, and alongside my co-presenter, Dr. Sam Graham, we're going to present our work on the conceptual model development for a pilot-scale geobattery as part of the Galleries to Calories research project. For a bit of context, the Galleries to Calories project is funded by Geothermal, and it began late last year. The project is led by Townrock Energy and the University of Edinburgh, and the research consortia consists of academic partners from Scotland, Ireland and the US, as well as industry and local regulatory authorities. Maybe skip on to the next slide, Sam. Yep. So the aim of the project is to facilitate and demonstrate the use of legacy mine workings as recycled heat storage and transport networks. Our study area is the University of Edinburgh's Easterbush campus and the surrounding conurbation, which is located to the south of Edinburgh. And at this site, there is an opportunity to recycle waste heat from a data centre into legacy mine workings associated with the former Roslin, Ramsey and Burley collieries. The rationale for the project is that by recycling this waste heat into the subsurface, it may allow for the managed sustainable recharge of low enthalpy geothermal heat in the area, making it available for regional heat extraction in the surrounding residential areas. One important feature of the project is to install a field test site where the hydraulic and heat transport characteristics of the legacy mine workings can be investigated. And to inform this aspect of the project, a conceptual model of the mine workings has been developed. And to talk you through this, I'll pass you over to Sam.
Thanks, Sean. Just following up on, I'll give you a bit of idea into sort of the regional setting of the collieries that we're dealing with and the wider sort of conurbations and heat demand. So essentially, we've got a competing facility which can act as a heat dump over towards the southeast of Edinburgh, southwest of Edinburgh. Is then sort of essentially directly in line with a chain of collieries exploit shallow subsurface heading towards centre of population towards Edinburgh in the northeast. The collieries themselves closed in the late 1960s. Be replaced to exploit typical reserves via Bilston Glen colliery at about twice the depth, which eventually ceased operation in the 1980s. The coal seams that we're aiming to target are actually sort of older than the ones that are being targeted by existing schemes in the upper court measures with Gateshead district heating system and the UK GEOS. Just so for a bit of context as to where we're actually targeting, but I'll now move on to sort of talk about the architecture of the mine system that we're dealing with and the implications that may have for heat transport. So the collieries are all they're located on the western limb of a regional syncline, which essentially forces all seams to be dipping very steeply at about 70 degrees towards the southeast, which gives us a sort of set of parallel colliery plates, if you like, that are all linked together at depth via a pit bottom roadway, which means in theory each panel can sort of act sort of thermal store in isolation from its own, only potentially compromised by local cross-cutting between the seams. In order to work these, most of the sort of major roadways work from that pit bottom roadway and then sort of essentially pillar and steel work out the panels more locally as you work up the system. And we can sort of see evidence of this from the way that they're actually sort of displayed in the mine plans, where your pit bottom roadway extends out from the shaft, and then you have your panel of coal essentially worked upwards at a steep angle from that, where these bottom roads essentially connect the whole system together, which only means you can potentially have a short circuit for heat at the deeper levels in the majority of the cases. A little bit more complicated than that, though, in terms of what seams we could pick for heat storage in the geobattery, because although they are theoretically sort of parallel heats that trend towards the northeast, each, for various reasons in the mine's history, will have been worked to various extents. So some are mined fully to surface, and sort of the schematics of A and B. Some are mined shy of the surface, as in panel C. Some are worked in sort of very local isolation, as in panel E, and then some are sort of a hybrid of shallow and working, as in D. And this all has implications for how we may choose to exploit a panel in for heat storage, because obviously if the work to shallow depth, are they flooded enough at shallow depth to take the hot water? If they're in a hybrid mode, does that imply there's faulting in the area that means we may have some structural concerns for heat transport? Or if we have got a local panel, as we've got in this example from the Great Seam in the middle figure, will that have implications for our ability to pull fluid out, used for put out of the system? We saw some of the issues that they had in Gateshead, with similar issues with the system acting in a sort of confined manner. And in some of the seams, there is sort of roadways between adjacent seams, which we can see in the Peacock seam example here, where these sort of brown lines are essentially local roadways that are between the next seam above and the next seam below, which have the potential to act as short circuits on the system. So I'll give you an idea of some of that sort of single colliery unit. The 3 collieries we have essentially act as a big regional chain of 3, each with their own sort of local characteristics that we need to consider. Roslin Colliery is where we're aiming to start our field study and put the heat in. That colliery is highly compartmentalized by regional scale faulting, which has implications for how we're going to move the heat from one into the other. Burley Colliery is crossed at shallow levels by regional watercourses, which poses potential risks for how that colliery system is going to interact with the subsurface and potential pathway for any mitigation we may need to take. Which is particularly seen in this old mine plan for the Bilston Burn, where these red circles essentially demark a lot of old shallow shafts and adits that potentially link these workings to near watercourse. Although these are only not on the modern mine abandonment plan, so we think these may be fairly isolated from the rest of the main colliery workings. And then the final colliery is Ramsey up into the northeast. And this is cut by a major fault. That fault is only crossed at significant depth, so may act as a sort of final barrier on heat flow within this particular battery project. We've done some limited work on the hydrogeology up to now to sort of try and characterize the connection between the regional water and the mines, where we're finding about 1 millimeter of recharge per day is able to account for what we see in the stream hydrographs at Musselburgh. The North Esk is about 30 to 50% base flow fled, although we don't know what the current state is with Bilston and the Kilburns, but that will be addressed in future work. And then I'm running well over. So once we've got our chain of collieries, we've been to the BGS to look at the mine plans for this set of 3 collieries to identify viable seams that can act as a full flow pathway from the Roslin Colliery in the southeast through to Ramsey in the northwest. And we, for practical reasons in terms of sites, land that we've got access to and depths we can afford to drill to, we've identified the Kittlepurse, the Peacock, and to some extent the Blackchapel as a set of seams we want to use for this pilot project, because they've got that large degree of through connection, and there's through connection between the 2 seams themselves, which gives us redundancy in being able to potentially move that heat between collieries. So if we can't get it across the faults in one seam, we might get it across in the other, which we can see here where the Peacock seam has been actively mined across and then mined through into the Peacock above, and then again in the sort of the more distal fault it also crosses. So we've got that ability to get heat out of Roslin into Burley, and then we've only got this deep roadway at about 300 meters depth that cuts that final fault. So we think the heat would eventually stop shy of that in Ramsey. And the sort of final question we're asking is, are we flooded enough really to make this work? And essentially, we know that from water level measurements in a colliery on the other side of the regional syncline, that they're in lockstep with shafts in in our proposed geobattery area. However, in the east, we know that there is a connection to deeper workings, which we don't have on the west side. So which is essentially implying that the faulting on the west side must play some role in how water rebounds, but that is part of ongoing work to actually ascertain quite how the rebound has been facilitated in the geobattery area itself. But to conclude, I will pass over to Sean just to sum up, and then we can hopefully take some questions if we've got time.
Thanks, Sam. Yeah, so just to kind of take a step back, yeah, so building on the conceptual model, over the coming months and years, the project will seek to demonstrate the concept of the geobattery and investigate how it could be replicated elsewhere. And we'll do this by developing a field test site, conducting local and regional monitoring of water quality, hydraulic testing of the borehole, numerical modelling of the thermal resource, but also developing kind of the techno-economic case and heat ownership models related to the geobattery approach. And the purpose of this slide is just to kind of highlight the opportunity that exists to replicate this approach elsewhere. So like many of the former coalfield areas, there are communities in central Scotland that have high levels of fuel poverty, which are co-located in areas which have been formerly mined. But there are also plentiful opportunities where waste heat could be recovered from and recycled to contribute to meeting local heat demand. And it's through this managed kind of holistic approach, considering the geoenergy resource with the local heat demand and waste heat resources, that we can begin to decarbonise these communities whilst also alleviating fuel poverty. And I'll conclude with that. Thank you.